is the calculus practice quiz I gave you guys. It's got derivatives. It had limits. It had conditions and limits, and second derivatives and a related rate. So it's about half of the first semester of calculus, maybe a third, a little less than that. First thing you should do with this limit as x approaches 3. Plug 3 in here. Did you guys check that 9 minus 12 plus 3 was 0? Okay, good. Then it's factoring. Then it is factoring. All right. And I get x minus 3, and it's x minus 3. And it had to be x minus 3 because we knew the x bottom was 0, guys. It had to be there. These cancel. I get 1. So I have 1 over 3 minus 1. So how about negative half? How about negative half? All right. All right. So everyone, there are 2 distinct ways to do number 2. We plug in 4, and you notice the bottom is 0 again. All right, believe it or not, guys, I would factor 2, and I'll show you that in a second. I don't think many of you probably saw that as a factoring problem. I see it as a factoring problem. I think most of you guys probably saw it as a conjugate problem, which works. And you multiply it by the conjugate, I hope. And everybody, remember, when you do conjugate work, you just got to drag your feet. Don't multiply out the top until you see what happens where the conjugate goes. And everybody, lo and behold, x minus 4 is canceled. Square root of 4 plus 2 is 2 plus 2 is 4. All right? All right. This is probably how you saw it. I would not do this. Everyone, I see that the top is a difference. The top is a difference. So I know any difference will factor. And I notice that the square root of x is the square root of x. And I notice the square root of 4 is 2. So watch this move, everybody. I know for a fact that I can factor the top into this. And I want you to look at it, understand it. I think this is much faster than the conjugate. Right? This factors, the top factors, because it's a difference of 2 things that you can take the square roots of. Everybody with me? Boom, boom. It's still 4. It's still 4. But I'm telling you, the blue way is a little faster than the conjugate way, in my opinion. All right. All right. You guys got that. Everybody, on the answer key I email you. On the answer key I email you, I actually do this out for you. This is not the way to do this. This is not the way to do this problem. Everybody, it's a parabola between 0 and 1. I don't care what it looks like. Guys, I want the average rate of change. I want the slope of that secant line. So all I need to do is I will change y to f of x. F of 0 is 1. Do you guys agree? F of 1 is 3. 3 minus 1 over 1 minus 0. The answer is 2. The average rate of change is 2. If you do the green out, you will get exactly the same answer. I did do it on the answer key. I will email you. You should rather hit your thumb with a hammer or a hammer with a thumb or something. Because listen, if you want to induce pain, this is the way to do it. Guys, you only do this green method. What if I asked you for 8 different places? Then you want to do the green, right? What if I told you I wanted the average rate of change starting at 0 going to 1, starting at 0 going to 2, starting at 0 going to 7, starting at 0 going to 3.2. Then you want to do that because you have A and H changing. But if you have just one place, boom, it's done. All right. Now, everyone, on the stuff I send you for 4 and 5, it will show all the steps. I am going to remember that when I see this is a quotient rule. So when I look at this, I see a quotient rule. So, and actually, I can do it as a product rule too, but I'm going to show you the quotient rule. All right. F is 3. G is 5 to x to the 5th plus 2. Everyone, we have memorized that the derivative of fg is f prime g minus g prime f all over g squared. All right. I know that the derivative of 3 is 0. Everybody with me? So, all right. So when I do y prime, I go 0 times g, because f prime is 0. I didn't even rewrite 5x to the 5th plus 2 minus. Now I have 3, which is f. I just put the f there. Times derivative of the bottom. How about 25x to the 4th? All over the bottom squared. And if I want just to get rid of the 0, I'm going to do that. There's the answer. Negative 75x to the 4th over 5x to the 5th plus 2 quantity squared. All right? All right, everybody. I should have said this at first. This is a rational function. Polynomial over polynomial. So the point is it has to be quotient. Guys, when you look at number 5, it is not a trig function. Number 5 is a composite. Does everybody follow me? It's a trig and it's a composite. It's a trig and a polynomial for an argument. So it has to be the chain rule. The derivative of sine stuff is cosine stuff times the derivative of stuff. All right? And that is the first 5 problems today. All right? All right, problem 6 is another derivative. Find y prime. You had to see that it was a product rule. All right, it was a polynomial times a composite trig polynomial. So this is a chain rule, and this is just the power rule. Okay? Either way, you have f and g. So everyone, the one thing I want you to practice is not having to write f is this, g is that. So I'm going to do the derivative as I go. I'm going to take the derivative of this first. So y prime equals derivative of secant is secant tangent x. And the argument never changes. But then you got to go times the derivative of the argument, which is 10x to the 4th. Times just that stuff unchanged. Negative x squared minus 2. For the sake of spacing, I will put a big old black plus here and we'll go to a new line. And then the bottom doesn't change. We go, hey, it's f stays the same, so it's secant 2x to the 5th times the derivative of, which is just negative 2x. And we are done. I said don't simplify. I said don't simplify, it's just that two-term expression. Or two-term expression on the right hand. Now, Nicole, almost for sure on the AP test, well, I'm all over the place. On the AP test, they would factor out the secant. I don't know if you caught that.
Oh, okay.
What if they have just like cosine?
So they on a multiple choice test, I can almost guarantee they would do this. They would distribute this. So it would look something like, ugh. No, it's kind of ugly. That's what my wife tells me all the time, Austin. All right, so everybody, I'm going to cut it here. This is good practice. If I go single screen just for a second. Now, there's a couple of rumors going around. Actually, you can study calculus, and you practice at home, and you do get better. That is true. That is a rumor that I know you guys don't believe. The other thing you don't believe is that doing the same problems over and over again doesn't help you. It helps you a lot, so you're really good at them. So you can practice when you see it in class, so you are a machine at them. So in college when you take notes or record or whatever, okay? You new hipster kids do. All right, keep practicing. Calculus is fun, damn it.